Bangladesh. Hello everyone. I'm starting the session on Amazon ECS on Amazon Fargate. Basically, it is some kind of advanced level session, but hopefully I'll try to keep it excited for you. So, a few words about myself. I've been working in the industry for like last 10 years almost, primarily focusing on cloud platforms. Have good level of experience on Amazon cloud platform, working in the working with the services they offer for like last 8 years almost. I've received quite a lot of certification from them, including professional and specialty level certifications. I've also worked with other cloud platforms like Google and Azure. I've got good expertise designing serverless application on top of cloud. And as a DevOps engineer, I'm a big fan of automation and always love to learn. Then I like to teach. So yeah. So here I've summarized the course into two modules. First, I'd like to discuss the benefits of microservices. Then I'll try to dig into Fargate and ECS components, and we'll discuss their fundamentals. Obviously, the load balancing and scaling part explanation will be there. What I'll do, I'll just first explain the benefits and the idea at a high level. Then I'll jump to the demo section and deploy a sample application. And then I'll start going through the slides and go back and forth on the deployed solution and to show the practical aspect of the situation or the project or the service details. Yeah, so AWS Fargate and ECS. So before diving deep into this the topic, I'd like to first to keep everyone on the same page. I'd like to throw some light on the benefits of microservices. So microservices, also known as the microservice architecture pattern, is one kind of architectural style that structures an application as a collection of services. So SOA, or service-oriented architecture, in modern days has evolved into microservice-based architecture pattern. So because it's highly maintainable and testable, these services are loosely coupled, they are independently deployable, and they are organized around business capabilities, and they can be owned by small teams, or as Amazon says, they can be owned by pizza teams. So these are there are lots of benefits of microservices, because the challenge of modern time is to maintain the team agility and keep up with the technology, and as well as the frequency of delivery actually becomes a big challenge for the tech teams. That's why tech teams are preferring microservice-based architecture nowadays, because it gives developers a lot of independence. So small teams can work in parallel and can iterate faster than larger teams. It offers isolation and resilience. So if a component dies, a new component can be spun up very quickly. Each and every component can scale up and scale down independently, whereas at a monolithic architecture, you'll have to scale up the whole stack to scale a particular small service within the monolith. Life cycle automation can be done because microservice has opened the door for continuous delivery and continuous deployments. So complex deployments or deploying a part of the services can be done using this microservice pattern. And microservice actually opened the door to various architectural patterns like event-driven architecture, domain-driven designing, things like that. So based on a microservice pattern, what a typical deployment in Amazon cloud will look like. So obviously, Amazon will be using its native services to activate the APIs and to run the scaling and the automation parts. So for example, if API is deployed on example.com and we have two uh, subpaths which are exposing service 1 and service 2, will be having a ELB on every APIs, and behind the ELB will be having the ECS cluster or the microservice running in either Fargate or either EC2 or in ECS. And obviously we'll be having the Amazon Route 53 as the core DNS provider. So I'd like to quickly move to a demo where I'll be deploying a simple service using Terraform, and then I'll explain the subsequent slide in light of that deployment. So I have prepared a Terraform stack for this demo. I'll just quickly go through the components and then back and forth with the slide so that everything actually makes sense. This is Terraform. Terraform has become really popular and has become one kind of de facto tooling to deploy infrastructure. And it is offering very stable modules to deploy resources on cloud. So what I'll do, I'll just quickly spin up.
Sorry, Kamrul, can you please say something about the Terraform?
Yeah, sure. So I have not actually prepared a slide for the Terraform itself, but I'll just go through the configurations that I have in this.
Actually, we need to know what is Terraform and why it is used actually.
Oh, okay. So I'll just explain Terraform from the Terraform's website. So Terraform is so for example, we have our source code maintain version control in Git, right? But we are deploying that source code in different cloud providers. For example, we are spinning up EC2, or for example, pushing our images to ECR. But to create this ECR resource, for example, what we used to do, we used to go to the console and then click few buttons here and there, and then the repository gets provisioned. What is happening here is that the resources that are getting provisioned through the console doesn't have any version control system or doesn't have any log. But the source code that we are writing, each and every source code has its own Git log. So to keep the infrastructure in a version controlled environment, we can use this tool called Terraform. What it does, it supports a language called HCL. So if we go to HashiCorp HCL, you'll see that it's a configuration management language. For example, we have Go, which is a programming language. We have YAML file, which is one kind of configuration management language. We are using YAML to manage our Docker Compose files. So here, HCL is being offered as a language to manage our cloud resources. For example, EC2 resources, SSL certificates, routing configurations, load balancer, data parser, Lambda. There are many, all the resources that any cloud provider actually offers can be provisioned using this configuration language, which is called HashiCorp's configuration language. So for example, Here I have declared a module called ALB, or Application Load Balancer. ALB stands for Application Load Balancer. I have wrote here that the name of the load balancer will be the service name -LB, and its virtual private cloud ID will be something, and the target group port will be a port number, and I have declared here whether HTTP is enabled or HTTPS is enabled. So after declaring this in a source, instead of doing it from the console, what I did, I just wrote the configuration here. And if I just run Terraform plan, it will ask for a few variable configurations, but eventually after getting the variable configurations, it will just show the output here. So, let me just create the form.ev first file. And what I'm doing here is I'm just grabbing all the variables, and I'll have to just set all the values. I'm sorry. Let's quickly define few variables so that infrastructure can provision faster. So the region will be US -East 1, and staging for this application will be dev, and project name, for example, is demo. Project name space, for example, take availability zone will be like it will be a list of availability zones. So Amazon actually maintains availability zones within the data centers. So let me just pass two availability zones here. So each and every availability zones are isolated data centers. So here ECS launch type will be Fargate, and the target port will be like it. So these are the variables which I have called within the configurations or the application infrastructure setup itself. For example, here you can see when I'm creating a virtual private cloud, I'll be needing number of availability zones. Then this variable is getting called from here. Here you can see the availability zones are declared. So now if I deploy, it will not ask for any parameters because I've put all the default parameters here. So let me just run the plan or validation first. Okay, so the configuration is valid. Then I'll just run a quick plan to show you what will be happening when I'm planning. So now, if we look at the output, you can see it is creating a AWS IAM role resources. So what is Amazon IAM role resources? For example, I'll just quickly show you from the console. What we used to do, we used to create a IAM role or identity and access management type role, using the console. For example, what we used to do is to go to the role section and then press create role and fill up all these forms, and then the role gets created. Here using Terraform, what I'm doing, I'm actually writing all the steps within these TF files, and thus these roles, these policies are being provisioned. So in short, I'm creating a virtual private cloud. Then I'm creating a ECS cluster with Fargate provider, which will be running on the microservices. I'll be explaining shortly from the slides. It will create a repository to host the images, and the ECS cluster will be pulling images from the ECR or registry, and it will be running the services, and will be having a load balancer which will reverse proxy the request to the services running in ECS. And I have not added any domain here, but it is totally possible to add any kind of domain that you have control of, but we'll be using default load balancer DNS for now. So the plan looks okay. I'll just apply this, and it may create it may take a few minutes, 1 or 2 minutes to deploy all the resources. Let's say yes, and it has started with ALB and things like that. So let it just try to provision all the resources. Well, I'll go back to the slide to explain what is actually happening. So back to slides. So ECS and Fargate. What is ECS and what is a Fargate? So ECS actually stands for Elastic Container Service, and Fargate is the capacity provider for this service. So there are other capacity providers as well. For example, if we go to a few slides ahead, you can see ECS cluster has 3 providers. To be honest, it has Fargate, which is serverless provider, which is a bit expensive, but it takes away the complexity of the scalability. We have ECS as a Linux provider, and we have EC2 with Windows provider. So the .NET or Microsoft based solutions which actually requires Windows environment, the capacity providers it uses is Windows and EC2. So ECS is really highly scalable, fast. It can be easily managed using Amazon services. We can host our cluster on serverless infrastructure that is actually managed by Amazon ECS by launching our service or task using Fargate launch type. So here you can see this Fargate is actually a cluster type or capacity provider. So for example, I guess the resources being provisioned, I should be able to show the type of the cluster that has been provisioned. Yeah, so here you can see a cluster has been provisioned, and you can see I guess the new UI is not showing up here, but the default the cluster configuration is set up and linked with Fargate provider actually. So here you can see when you are creating a cluster from the console, what you'll have to do, you'll have to provide a name. You need to select a VPC. You need to select the subnets, and then by default Fargate provider is selected. You can enable EC2 instances or external capacity provider as well. So by default, a cluster, when cluster is created, the capacity provider is set to Fargate in Amazon ECS. Now we have, for example, let's go back to slide. So here you can see ECS can be used to schedule for placement of containers, and it can isolate, and it can offer your availability requirements, fulfill your availability requirements. Amazon ECS can eliminate the need for us to operate on our own cluster management and configuration management system, and we don't have to worry about the scaling part when we are using Amazon ECS. So the objects that we have under ECS are 4. So first one is cluster. So the solution that or the infrastructure that I have just deployed, it has provisioned all these components that I'm talking about in the slides. So for example, we have our clusters. So to make it a bit more clear, let me just show this small image, which actually will clarify things. So it is one kind of box-like structure where we have the cluster, and within cluster, a cluster actually has the capacity provider like Fargate or EC2. Then within cluster, we have our services running. So services are like just like Swarm service or Kubernetes service, but it is actually taking its service definition from the task definition. And within task definition, we have our container definition, for example, the memory, CPU, entry points, things like that. So this is one kind of layered architecture. So from the console, I'd like to show you each components. So here you can see we have our cluster settings, and within the cluster, the infrastructure that I provisioned, it actually declared a service. So this service is attached to the load balancer that I have just deployed. Okay, wait. Let me just deploy a sample application in this stack which I have just provisioned. Then I'll explain how the request response cycle is actually working. So here you can see this service has a task definition, and this task definition, if you go inside, you can see. Okay, so I guess I'll just have to remove Nginx from here, and I'll just link the ECR, that is the Elastic Container Registry, to this definition. So if you look at the repositories, you can see this repository has just been provisioned, and it is not linked in the task definition. Just let me just quickly modify the task definition and link the repository. So if I go to ECS, I'll see. Okay. So what I've done, I've just updated the container definition here, and I'm linking the ECR repo here. Now I'll just so here you can see this Terraform has actually made infrastructure management really easier, because as you can see, this was not linked. What you could have done was that you could have just gone to the console and click here, and then search for the settings, and then update here, write something here, or put the image repository URL here, and then click create button. But you're not keeping any history of the changes that you are making on the infrastructure. Whereas, since this is a code-like settings, if we push it to a Git and we keep the history, then the infrastructure level changes are clearly visible. So I'll just apply the new change that I've done, and I'll just show you how it actually reflects in the infrastructure. So it is showing you the level of changes that you're going to make. So I'll just click yes. So yeah, so the change has just been applied. Let's just go back to the console and check. So here you can see we have a new service definition version 2, and you see that the image pointer has changed and it is pointing to the ECR repository here, but there is no image here. We'll just have to push a sample image here and we'll see the live application at the default load balancer DNS. So let me just go back to the Cloud9 and just let me just grab the push commands. I have to log into the ECR and then run few build commands to push the image to the ECR. Now I'll just tag the image and push it. Tag, and this is the push. So the image is pushed. Let me just refresh and see. You can see the latest image has been pushed. By the way, ECR actually provides you a good scanner which actually can scan for vulnerabilities. Okay, so let me just check how the service is doing. So in ECS, like Docker Compose or Kubernetes service, we have continuous running service which actually controls the deployment part. So you can see a new task has just been spinned up, and if you look at the service level settings, you can see the deployment can be controlled in a very stable way. For example, I'm not destroying my old container or image or service before deploying the new one. So this kind of deployment level of settings or configurations can be updated very easily from the services. I'm just waiting for the task to be live so that I can show you how it is doing. Okay, so it is showing that the old task has been eliminated and a new task has been created under the service. So I'll just grab the load balancer DNS quickly and see if the application has been. Yeah, so the sample application has just been deployed. So I'd like to just explore the request response cycle with you so that I can just help you guys understand how everything is working here. So this is the DNS of the load balancer. Now, if we go to the load balancer section, for example, here, you can see it is actually listening on port number 80. It is possible to obviously configure HTTPS and configure a listener on 443, which is the HTTPS port. And when request has been successfully reached the load balancer, then the request is terminated and the request body is forwarded to this target group. So when you check the details of the target group, you will see that the container with a static IP or a private IP is listening on that end, and that container is actually this task. So this task is receiving the payload and it is generating the response, and thus we are seeing the output in the default DNS, sorry, load balancer DNS. So this is just a sample application and a simple setup. So going back to the slides. So we I have already showed you the task definition, sorry, the service, Fargate cluster, and task. So that there is another thing called task definition and container definition. So it's nothing but a container image level settings, and a task definition is a task definition blueprint for application that describes one or more containers through attributes. So there are lots of attributes to be configured in a task definition. So for example, if I go to the deployed application, sorry. So if I go to the task definitions, here. So when we open up the JSON tab, you will see all the configurations written in details. You'll see it is asking for the family, the revision number, the network on which this task will be running, the capabilities, and we have EC2 and Fargate. And required capabilities are given to Fargate, so it will by default will be using Fargate. And the task is allocated 0.25 virtual core, and the memory is 2 GB. And we have option to configure environment variable and secrets as well, right in these settings. So there is a graphical window is available to configure all this stuff. But here what I have done, I have configured all this using Terraform in the container definition module. So this is how we do things as a DevOps engineer. Yeah. So back to the slide. So as I've already mentioned, there are apart from Fargate serverless, we have other capacity providers like EC2 Linux, and the clusters are actually region specific, and cluster can contain tasks and launch types. So here I'm explaining what you can do with what kind of settings that task definition actually allows you to configure. As I've already showed you the JSON config, you can see it can have the definition of the Docker container. It actually acts like application blueprint. It actually allows you to set up CPU and memory, and it gives you the option to set up login configuration, and it gives you the option to mount volumes, external or NFS type storage volumes. So these are a few attributes Elastic Container HT has. It is fully managed, highly available. I mean, if you see the growth of ECR compared to the Docker Hub, it is really amazing, because ECR has been released after Docker Hub, and as soon as it got released, users started to comparing the service quality and the price with the Docker Hub services, and the ECR service really growed. I mean, it's right now it is like mostly heavily used Docker image registry. It has good integration with the identity and access management system, and it actually doesn't have any upfront fees. So this is how ECR actually works. As you can see, I've already showed you the service actually pulls images from the ECR, and it runs the container within the available provider, for example, Fargate provider. And this is really helpful during the release and deployment process. So this is a bit more detailed scenario when our application microservice-based application with 2 API endpoints has been deployed. You can see we have request coming in from Postman client. It is hitting the application load balancer, and then based on the routing rules we have in the load balancer, it is actually routing back to different target groups that I've already showed you. In this case, it is routing to user management service and the notification service. So deployment, there are many deployment configuration that is supported by ECS deployments. We have canary-based traffic shifting-based deployments. We have rolling updates. We have blue-green style deployments, things like that. So yeah, that's it. I believe I've covered a few things at a very high level. If the community is interested in that case, I can take few deep level sessions, because I've been using these services for last 3 to 4 years. So yeah, if there's any question I'd like to answer, I'll happily answer. I hope everybody's awake.
Thank you very much, Kamrul. Thank you for your session. It's a very much interesting session, and hopeful professional will be very much helpful and enjoyed this session. And we are hopeful to arrange more session on this topic. One question has come from the event side is that what are the challenges for deploying ASP.NET application into the AWS? And the application is following the architecture of microservice. Is there any challenges?
Yeah, of course. I mean, for example, it's not like there will be some kind of hard constraint or due to some kind of lack of features that you will not be able to, you'll be facing difficulty to deploy ASP.NET application on top of Amazon, because all the technologies are covered by Amazon. Personally, I have not deployed ASP.NET based application, but as I've already showed you, Amazon ECS already has available capacity provider of EC2 and for Windows based environment. So the way I'm configuring it for Fargate, following the same process, you should be able to run ASP.NET based application and deploy it on Amazon EC2 and Windows based providers.
Okay, thank you, Kamrul. Second question is that if any existing customer from Azure wants to migrate to AWS, then what are the challenges are there for the migration? AWS platform to Azure platform to AWS. Is it possible also?
Yeah, of course, it is totally possible. And of course, the Amazon sales team is really active in the market and trying to convince all the Azure customers to migrate their services to Amazon. It actually depends on how the application was deployed in Azure. For example, if it was deployed in Kubernetes environment, in that case, in Amazon, they have EKS, Elastic Kubernetes Service. And so it will be a typical kind of migration kind of scenario. For example, first somebody will spin up a EKS cluster in Amazon, then will be migrating the containers from Azure EKS to Amazon EKS, then use some kind of circuit breaker pattern or traffic shifting pattern to migrate the solution. But if it is very much tightly coupled with the Azure service components, in that case, they might face some difficulty, but I guess it will be easier if they were using some service like Kubernetes. But it is totally possible and should not be that much of a headache to migrate applications from Azure to AWS. But if the requirement is like some kind of zero downtime based migration, that might be there's some challenges, but those can be overcome based on the application traffic and users base.
Is there any migration tools exist for migrating from Azure to AWS, or it is not required? You think?
I mean, the Amazon actually offers data migration tool. For example, there is a
Okay.
service called DMS.
But
Using that,
is there any migration tools for application migration? I think
there are
it's not
some.
required actually, right?
Yeah, there is a service called SMS or server migration service, but
Okay.
it is actually specific to the on-premise system. It is not specific to Azure. It actually first we'll have to examine what is the setup in Azure, then we can define the tools required.
Okay. Actually, if the application is not using any Azure services, then it will be easy for migrating from any cloud platform to AWS, right?
Yeah, of course. I mean, as I've said, if the Azure in Azure they were using Kubernetes kind of service, in that case migration should be easiest. Or if they are using some kind of just flat virtual machine and configure the microservices there, then things should be really pretty simple. But if it is tightly coupled with the Azure services, in that case migration may get a bit difficult, but it's totally possible because Amazon has all the equivalent services that Azure has or offers.